Hello and welcome to the Chanda Academy. Today we're going to solve an exercise of the chapter 1 about real sequences. In this exercise, we will have to determine the sign of the following expressions depending on the value of n, an integer. So let's begin with a. So it's getting more and more difficult. So a, we've got a is equal to 2n plus 1. With n, an integer. Okay, so we know that integers are, so n is superior or equal to 0. So it can be 0, 1, 2, until the infinite. So as 2 is also positive, we've got 2n that is superior or equal to 0 for all n. And it's equal to 0 when n is equal to 0. And we've got 1 that is strictly superior to 0. And so something that can be either superior or equal to 0 plus something that is absolutely superior to 0 is equal to something that is strictly superior to 0. So, in conclusion, we've got a strictly superior to 0 for all n integers. And we have solved the first part of the exercise. Number 2, so b is equal to n squared minus 14. Okay, so here we can see at first look that when n is going to be large, we will have something large minus something quite little, and it's going to be positive. But for n is equal to 0, for instance, we've got b is equal to minus 14, so something negative. Now we want to know the limit of n when n is going to be either negative or positive. b is going either to be negative or positive. So let's solve. N is superior, n squared minus 14 is superior or equal to 0. So let's solve this inequality. So n squared is superior or equal to 14. So I just added plus 14 on both sides, plus 14. So now I will compose by the function square root on both sides, okay, square root. And as square root is increasing for all x in its domain, and we can use the square root function because we've got something that is positive and something that is positive. We do not change as it is increasing. We do not change the sense of the inequality. So we've got n superior or equal to square root of 14, and we have to know that square root of 14 is something between 3 and 4 not included, because we've got 3 squared that is equal to 12, that is lower than square root 14, but lower than 4 squared is equal to 16. So if we add the square root to the 3 to the inequality, we will have, we've got a 9 here, and 9 here. We will have 3 lower or equal to square root of 14, lower or equal to 4. So this solution is between 3 and 4. And so we want n greater or equal to 4. to 4 because we want this to be true. So we cannot choose 3 because for 3 the expression will be negative. But the limit is something between 3 and 4, so let's choose 4. Okay, so we've got b superior or equal to 0 equivalent to n is greater than 4. And we've got b is negative is equivalent to n between, so n between 0 included and 3 included. Okay, so we have solved our problem, and as the limit is something between 3 and 4, we can also say that as we do not reach the limit, this inequality is a strict inequality. Okay, so we could say that. Now for the third one. Okay, we've got c is equal to 2n squared minus 2 square root of 2 times n plus 1. And here we have something with the square root, the 2, the n squared. We have something that could look like an identity. Okay, so let's try to identify the terms, and sometimes because the exercises are done for you to solve it easily, you will find those identities. So maybe this will be a c squared, okay, a b squared, sorry, b squared. If that is a b squared, we will have here an a squared, and here we will have 2ab. Okay, so if b squared is 1 and we have a minus here, we have a minus here, maybe it is because we have something like a minus b squared is equal to a squared minus 2ab plus b squared. And let's identify. So if we have a squared here, we will have c is equal to square root of 2n minus, and 1 squared is equal to 1, so minus 1 everything square. So this is an hypothesis, okay, an hypothesis. Let's just develop the expression. So we've got, so we tried to solve this by a sketchy way, and now we want to make sure that this is the right solution. So let's develop. So square root of 2n everything squared minus 2 square root of 2 times 1 times n plus 1 squared is equal to 2n squared minus 2 square root of 2n plus 1. And we have the expression research. And so in conclusion, we have this. So c is equal to square root of 2n minus 1 squared. Okay, and so if this is squared, is a square, okay, so that's a square. And so we know that a square is always either positive or equal to 0. So positive or equal to 0. Okay, so this gives us the sign, but we will go a little bit further and we will try to see if it's possible that this square is equal to 0. Okay, so it will be equal to 0 if it exists a n such as square root of 2n minus 1 is equal to 0, because x squared is equal to 0 is equivalent to x equal to 0. And this would be equivalent to square root of 2n is equal to 1, would be equivalent to n is equal to 1 over square root of 2. And this is, of course, impossible, because here we have an integer and here absolutely not an integer. And so we have this squared that is always superior or equal to 0, and we just proved that it was not equal to 0, so C is strictly superior to 0 for all n integers. So the exercise goes from the less difficult to the most difficult, and now the most difficult, because we will have to think a little bit to solve it. So d is equal to 2n minus 6 times n squared minus 8n plus 1. So here we have a product, and we will call d1 the first part of the product and d2 the second part of the product. And we will have d that is positive when we will have at the same time d1 that is positive and d2 negative and d2 positive, or d1 negative and d2 negative. So we will study the behavior of d1 first, then the behavior of d2, and then in a table of value we will find when d is positive or negative or equal to 0. So let's start by the study of d1. So d1 is equal to 2n minus 6 with n an integer. So we will try to find when d1 is superior or equal, so greater or equal to 0. This is equivalent to 2n minus 6 superior or equal to 0. We will easily find the solution of this inequality. So 2n greater or equal to 6 equivalent n superior greater or equal to 3. Okay, so for d1 we will have n, the sign of d1, so starting from 0 there is a special value in 3, because in 3 this d1 is equal to exactly 0, so 3, and then plus the infinity, and we will have a 0 here. Before that it will be negative, and after that positive, because of what we just proved. So this is the table of value of truth, if you want, of d1. Then let's do the difficult part with d2. Okay, so d2 is equal to n squared minus 8n plus 1. So yes, and we will try to solve this inequality, okay, so greater or equal to 0, by studying the behavior of the associated polynomial function, which is f that given x gives x squared minus 8x plus 1. So d2, if you want, d2 is equal to f of n. Okay, so how to study a function like that? I hope you know in grade 11, so we have to find the delta. So if I call what's here 1, so there is a 1, an hidden 1, A, minus 8 is called B, and the 1 is called C, because we want to have something like A x squared plus bx plus c. Okay, so we've got delta is equal to b squared minus 4ac is equal to, so minus 8 squared is 64 minus 4 times 1 is equal to 60. Okay, and in the exercise we are given the information. We are not given the information, but I will give it to you. Then that square root, so to know, not to know, but we will give you this information. Square root of 60 is approximately equal to 7.7. We will have to use this information later. So now we've got the roots of f. So let's call them x roots, are equal to minus b plus or minus, because there are two roots, square root of delta. And let's just see, this is very important, that then delta is strictly superior to 0, and this is because we have this is why we have this formula over 2a. So the first x root is equal to minus b when b is equal to 8, so 8 minus square root of 60 over 2. And we've got something that is approximately equal to 0.3 over 2 is equal to 0.150. So we've got something that is not an integer, okay? And x2 is equal to 8 plus 7.7, so square root of 60 over 2 is equal to 15.7 over 2 is equal to something like 7.850. Okay, so something between 7 and 8. And now we know because we've got a strictly superior to 0, that our function will look something like, this is always the same thing, like that. So no, because these are not the right root, but like that, with the first root x1 and the second root x2. So because 8 is positive, we've got the function f is negative between the roots. So in this interval, and then it's positive outside of the roots. And so let's use it in a little table of truths. So we've got n, we've got d2, so starting 0. Now we've got a special thing because a change of sign in 0.150, then another one in 7.850. Okay, and we've got the integers, so here 7, here 8. Okay, and so for 0 we will have something that is positive because we are on this part. between 1 and 7 included, we have, because included we have something negative, and after 8 with 8 included we have something positive. So let's sum up with D1 and D2 in a big table of value. So we've got N, we've got D1, we've got D2, and we've got D1 times D2, so is equal to D. And we will have 0. Let's remember that for D1 the special value is 3, so we've got 3 here with a 0, and before that it was, let's remember, it was negative. Okay, so we got negative, positive. Okay, and here we have a change for D2 with a 1 here, and then we got 7 change 8, and then plus the infinite, and we've got something, so negative, negative, and then it changes for D1 positive, positive, and for D2 we've got something positive, negative, then still negative because we are between 1 and 7, and then something positive. Okay, and so we just have to look at what's going on here. So minus times plus is equal to minus, because we do D1 times D2. Minus times minus is equal to plus. Plus times minus is equal to minus. And something times 0 is equal to 0. So we've got a 0 here. And then plus times plus is equal to plus. And you can give your answer using a table of value like that. So I will not conclude. This is our conclusion. Okay. So this last part may be a bit difficult, but you just have to practice and everything's gonna be alright. Always the same method. Okay. So hope you enjoyed the video. Bye.